A point in the polar coordinate system is r comma theta, where r is the directed distance from the pole and theta is the directed angle from the polar axis. You can think of graphing r as on the xy plane and theta as on the unit circle. Graphing on a polar plane is just like graphing on a combination of the unit circle and xy plane. You can treat these lines as unit circle lines, and they end in a radian or degree measure. These lines are used for graphing r and can be numbered 1, 2, 3, 4, 5, and so on. Here are some sample problems that we can begin with. For number 1, the theta measure is pi over 4. So first we have to find pi over 4 on our polar plane. It's right here. The r measure is 1. So you go down this line and you count out 1 from the center. Your point, 1 comma pi over 4, is right there. For number 2, the theta measure is negative pi over 3. Just like graphing on a regular unit circle, negative numbers go the opposite way from 0. So to find negative pi over 3, we go negative pi over 3 away from 0. And you end up right here. The r measure is 3, so you follow this line and go 1, 2, 3 out from the center. And this is 3 comma negative pi over 3. Our next coordinates are negative 3 comma 5 pi over 3. So again we find 5 pi over 3, which is right here, but instead of going out 3, because it's negative, you go backwards 3. So you follow this line, and you go 1, 2, 3. And this is the point, negative 3 comma 5 pi over 3. The final point is negative 2 comma negative 7 pi over 6. So again, you go backwards from 0, 7 pi over 6 radians, and you end up right here. And then the r is negative 2, so you go to the center, and instead of walking out 2, you walk out negative 2. So you go backwards 2, you go 1, 2. And this is the point, negative 2 comma negative 7 pi over 6. Sometimes you aren't always given r comma theta coordinates. Sometimes they are x and y. As you know, r comma theta is the polar form. X comma y is the rectangular form, and you can convert between them using these equations. First, we'll convert polar coordinates to rectangular coordinates. Here, x equals r, which is negative root 2, times the cosine of 3 pi over 4. The cosine of 3 pi over 4 is negative root 2 over 2. So x equals negative root 2 times negative root 2 over 2, which simplifies to 1. So the x-coordinate is 1. For y, you plug negative root 2 back in for r, and it's sine of 3 pi over 4. Sine of 3 pi over 4 is root 2 over 2. So y equals negative root 2 times root 2 over 2, which is equal to negative 2 over 2. So y equals negative 1. The coordinates are 1 comma negative 1. In this graph, I don't have an xy plane superimposed on top of the polar graph, but you can just guesstimate. It's about right here, which when we look back at the polar equation, it makes sense. It makes sense because 3 pi over 4 is right here, and negative root 2 would be around here. Here, we can convert from rectangular coordinates to polar coordinates. To find r, you sub negative 4 comma negative 4, which is the rectangular equation, into this equation. So r squared equals negative 4 squared plus negative 4 squared. R squared is equal to 16 plus 16. R is equal to root 32. When you simplify this, you get r is equal to 4 root 2. So that's your r coordinate. The theta coordinate, you can again sub these into the equation. So tan of theta equals -4 over -4. Tan of theta equals 1. Inverse tan of 1 is equal to theta. The inverse tan of 1 is equal to pi over 4. So the polar equation is 4 root 2, comma, pi over 4. And we can graph this by going pi over 4 and then going back 4 root 2, which is about around here. And you can check this by looking at your rectangular equation and saying -4 comma -4 is around here as well. Well, thanks for watching, and I hope this lesson helped.